Hello, my name is Steve Bowler, and welcome to the Juniper Border Gateway Protocol, BGP Lab number 6. In this lab, we're going to take a detailed look at Multiple Exit Discriminator, or MED. This is a BGP attribute, and what we're going to do is, if this network topology looks familiar, this network topology is from our previous Juniper BGP lab, which is lab number 5, in which we looked at the BGP attribute of AS path. In particular, we looked at AS path prepending. So we're going to be using the same network topology. And if you weren't with us with the last lab, let me go ahead and start out by giving you a description of the network topology. We have 6 routers, router 1, 2, 3, 4, 5, and 6. We are using logical systems within one physical Juniper router, and we are using logical tunnels to connect the logical systems together. If you're not familiar with logical systems, I have a couple of videos on logical systems. I would go ahead and watch those, but by now you probably have watched those. If you're not familiar with logical systems, what they allow you to do is create what's known as virtual routers within a actual physical Juniper router, and you can connect these logical systems together with logical tunnel interfaces and run routing protocols between them. You can do MPLS, MPLS VPNs, and other protocols. So that's what we're doing in this lab. All the logical tunnel interfaces equal LT-120.XX. For instance, the connection between router 3 and router 5. From router 3's perspective, that interface is LT-120.35. All of the IP addressing of the routers are as follows. Router 1, the interfaces are .1. Router 2, the interfaces are .2, and so on. Router 1 has a loopback 0.1 interface with 2 prefixes, the 1 network and the 11 network, both /24s. Router 6 has the loopback 0.6 with the 6 network and the 66 network, both of those /24s as well. So we are running BGP. Router 1, 2, and 3 are in Autonomous System 100. Router 4, 5, and 6 are in Autonomous System 200. We are running iBGP within AS100. Router 1 is a route reflector. If you're not familiar with what a route reflector is, I have a Juniper BGP lab that is devoted on route reflector basics. I would go ahead and watch that lab. So router 1 has a iBGP connection to router 2 and router 3. Router 2 and 3 do not have a connection or reachability to each other directly. So router 1 is going to be the route reflector and reflect the routes to the routers. Same thing with router 6. It is a route reflector as well. It's connected via iBGP to router 4 and router 5. Router 4 and router 5 do not have a iBGP connection to each other. And if you're not familiar with what route reflectors allow you to do, they allow you to skip the rule of all iBGP routers must be connected directly to each other. That is the iBGP full mesh rule. Route reflectors allow you to get around that, and that's what we have. Router 1 in AS100 as a route reflector, and router 6 in AS200 as the route reflector. If you want more details on route reflectors, again, I have a video on that. So I'd go ahead and watch that as well. We are running external BGP between router 2 and router 4, and also external BGP between router 3 and router 5. So let's go ahead and start with the brief discussion on the Multi Exit Discriminator, or MED. It is used to send to external BGP peers a metric in which the lower metric is preferred over the higher metric. And the MED is only advertised to the neighboring autonomous system and is not passed on to other autonomous systems. So for instance, if we had router 2 and router 4, router 2 is in autonomous system 100, router 4 is in autonomous system 200, and then say we had a connection up here from router 4 to, let's say, router 10, and router 10 was in autonomous system 1000. If we set the metric value on R2 and send it to router 4, router 4 would not pass this metric information on to router 10 in autonomous system 1000. So as you can see, the MED is only advertised to neighboring autonomous systems, or bordering autonomous systems, I guess you could say. And it is used to influence how traffic will enter your autonomous system. And some of the cases that we see is that the internet service provider or an ISP will advertise a MED to the customer autonomous system, either for load balancing reasons or to prefer a higher bandwidth circuit. So what we're going to do in this video is, say autonomous system 200 represents our ISP, we're going to influence how autonomous system 100 prefers or enters into autonomous system 200, and we're going to do that by sending metric values, or MED values, on R4 and R5 into our external BGP connections to autonomous system 100. Okay, so the first thing that we're going to do is we're going to start off, and in our first example we're going to set the MED value, our metric, on all of our routes within AS200. We're going to set a metric of 5000 on R4, send that via external BGP to router 2. We're also going to set the metric to 500 for the networks in autonomous system 200 and send that metric value to router 3, and we're going to see what happens. So the first thing we want to do before we get all of that set up, and I should say that we're going to also enable BGP trace options, do some show commands for verification. So what trace options will allow us to do, if you're not familiar with trace options, they will allow us to log critical events that are occurring in BGP, kind of like the debug commands within the Cisco iOS or on Cisco devices. The trace options perform similar functions in which we can name a file, and then what we're going to do is set what options we want to catch and send to that file. So the first thing let's do on router 1, we'll do a show route protocol BGP. We can see that we have the 6 network and 66 network. Let me real quick also touch on one more thing. We're not running internal or interior gateway protocols, IGPs. We're just strictly running BGP connections, and we are exporting the 6 and 66 network into BGP on R6 via a simple routing policy for the directly connected interface. Also on router 1 we're doing the same thing. We're exporting the loopback 0.1 into internal BGP and sending that to our neighbors. So that's why we see on router 1, when we do a show route, we see the 6 and 66 network from R6 in autonomous system 200. One of the first things that we can tell is that we are taking the path to router 2, through router 2 I should say. If I go on R1 and do a trace route to the 6 network, source it from the 1 network, the path that it's taking is the 12, 24, and then 6. If we look at our network diagram, that is going through router 2, then router 4, and then finally reaching router 6. That's for the 6 network. If we do a trace on the 66 network, and we'll just source it from our 11 network, we see the same path being taken. So the traffic from Autonomous System 100 to Autonomous System 200 routes, they are all going through Router 2 to Router 4 to Router 6. So before we get started with playing around with the metric value, or MED value, Multi Exit Discriminator, in Autonomous System 200 and sending that to Autonomous System 100, we'll go under Edit Protocols BGP on R1, and we're going to do the command set trace options, file, BGP, lab, this is BGP lab 6, so we'll do BGP lab 6 R1. Then once we have created our file name, we'll just do set trace options flag space question mark, and these are all the options we can flag within our BGP trace option. We'll do set trace options flag all, and then what we'll do is we'll just match on more specific events that are occurring in BGP. Let's go ahead and commit that. We're going to start on Router 5. We're going to set the metric to, or the MED value, to 500. And we're going to see what happens with these networks on R1, how Router 1 reaches the 6 and 66 network. We're going to see if there's any changes. So on our Router 5, we'll do Edit Policy Options, Policy Statement. What we're doing is we're creating our routing policy. We'll call it MED. And what we're going to do is we're going to create our term. We'll do set term 1 from route filter 6.6.6.0/24 exact. Then we'll also do the 66 network. So this is going to match both of these prefixes that originate from router 6. We're matching those two networks. And then within the same term, now that we have our match, we're going to do our action. In this case, set term 1. Then, if I do a space question mark, we have the option for metric. And this is our MED value. So we'll do then metric 500. We'll go ahead and commit that. Once we have our simple routing policy created, we'll go ahead and apply our routing policy as an export to eBGP and send this to Autonomous System 100. So go Edit Protocols BGP. We'll do Show. We see that we have the group eBGP, that's an external connection to Autonomous System 100. We'll do the command set group eBGP export and then MED. And this MED is our routing policy that we just created. We'll go ahead and commit that. And now we're going to go back to router 1 and see if we see any differences. We'll do show route protocol BGP. And it looks like the path is still going through router 2 to reach the 6 and 66 networks. We see that we have a MED value now coming through from router 3. I'm sorry, Yeah, that's correct. Let's do this. Let's get a better, we'll do another command, show route protocol BGP terse. And what this is going to show us is the med value, which is the metric 2 that we set. And we set this on router 5, and router 3 is advertising this to router 1, but router 2 is not. If we look at our network diagram, router 5 connects to router 3 directly via external BGP. So router 5, we can see, is sending a metric value, our med, of 500 via eBGP, and then router 3 is sending this metric value, or the med value, to router 1. So router 1 has to make a decision on what is the best path to reach the prefixes off of router 6. It's seeing a metric of 500 through router 3, and it's seeing from router 2 a metric of 0. And that is because the default med value is 0. And remember, we haven't changed anything with the metric on router 4 yet. So that's why from router 1's perspective, we still see the path. If we were to do a trace on the 6 network, source it from the 1 network, that's why we still see the trace going through router 2, router 4 to reach the 6 network. Let's look at our trace option file. We'll do show log BGP lab 6 R1, and then we're going to match on the 6 network 6.6.6.0. And what we see is a change for the 6 network with the gateway, which is router 3. The metric that router 3 is showing us, or advertising to us, is 500, and we can see that that is not the best value. So let's look at, on router 1, if we do a show route 6.6.6.0/24 detail, we see that the path being preferred through router 2 via the 12 network, that's the active prefix. The inactive is through router 3. The state is not best, and the inactive reason is that it has not the best in its group, and that is the route metric or med comparison. We see the metric that is being advertised by router 3 is 500, where the metric for router 2 is 0 by default. Another command that we can do is show route received protocol BGP. If we look at the connection from router 2, which is 12.12.12.2, we can specifically see a med value, and we see that there's nothing for the 6 and 66 networks. So that we know by default, if there's no value specified, that the metric or the med value is 0. Now if we look at if we do a show route received protocol BGP from router 3, which is 13.13.13.3, we are receiving a med value of 500. So obviously 0 is less than 500, and that is why the path we trace to the 66 network this time, source it from the 11 network, that is why we are seeing the traffic still going through router 2 to router 4 to reach the 6 and 66 networks, because the lower metric or med value is preferred. So the next thing that we're going to do, the next example, we're going to show you that we're going to set the med value on router 4 higher than it is on router 5 and export it via external BGP to router 2. That way, router 1 will now have to make a decision based on learning a metric value or med value of 5,000 through router 2 or 500 through router 3. So we should see the traffic be rerouted over the path with the lower metric. In this case, R1 to R3, R3 to R5 to R6. So 13 network, 35 network. Let's go to router 4. First, we're going to do a edit policy options policy statement. We're going to create our routing policy. We'll just call it med. We'll do a set term 1 from route filter 6.6.6.0/24, and we'll do an exact match on the subnet mask. And we'll do set term 1 from route filter and then match on this 66 network as well. Once we have matched those two networks, we're going to do our action, which is going to be set term 1, then apply the metric value or med value of 5,000. So we have our route filter created. Now let's go ahead and export this into BGP. We'll do edit protocols BGP. We'll do a show, and we have the group eBGP in which we are appearing with router 2. So do the command set group eBGP export med. Let's go ahead and commit that. On router 4, we'll go back to router 1, and we'll just do a show route protocol BGP. And now what we see is that the path being preferred through router 3. The med value being 500 through router 3, and the med value is now 5,000 through router 2. So obviously the path through router 3 is better because it has the lower med value. If we look at our trace option file, we'll do the command show log BGP we'll do the command show log BGP lab 6 R1, and we're going to match on the 6th network. We'll look at the last log file. And what I want to show you within this output is that our gateway, which was router 3, showing up the gateway is not best with the metric of 500. We can see that it has BGP has chosen router 3 as the new gateway. You can see that with the active keyword. And then we see router 2 is now advertising to us a med value of 5,000, and so we know that that is not the best. And that's what we are seeing within our trace option file. So the med from R1 is now the lowest, and that is the path that we are taking. Let's do a trace. We'll source it from 1.1.1.1. So the path is 13 network, 35 network to the 6 network. Let's do the same thing for the 66 network. Taking the same path, router 3, router 5 to router 6. One more command we can do to verify and compare the med values. We'll do show route protocol BGP terse. We're seeing the lower metric of 500 through router 3 and 5000 through router 2. So let's say we want to load balance between the links from Autonomous System 200 to Autonomous System 100. We're going to make it so that Autonomous System 100 is going to take the path from router 2 to router 4 to reach the 6 network, while to reach the 66 network, router 1 is going to go through router 3 to router 5. And we're going to do this by lowering the med value on R4 for the 6 network. And so what we're going to do is we're going to have to lower that value to something less than 500. So we're just going to set it to 250. So what we should see is that router 4 send the metric of 250 to router 2, and then router 2 is going to advertise the metric of 250 to router 1. So when this is all said and done, the 6 network should have a next hop of the 12 network, and the 66 network will stay the same, going through the 13 network, our router 3. So how we're going to do this, we're going to go to router 4, which is connected via eBGP to router 2. We have our simple routing policy. We're going to go under Edit Policy Options, Policy Statement Med. And what we're going to do is we're going to do the command delete term 1 from, and then we're just going to delete the route filter. We'll delete the 6 network from term 1. We're going to create a term 2 in which we match on the 6 network, and then we're going to set the med value to something that is less than 500. We're going to set it to 250. So we'll do set term 2 from our 6 network, set term 2 from, I'm sorry, I forgot route filter, 6.6.6.0/24 exact. Then we're going to do set term 2 then, and we're going to apply our metric value of 250. Then metric 250. Okay, so if we did everything correctly, we should be able to go back to router 1. If we do a show route protocol BGP terse, and what we have done is we have taken the metric of 5,000 that router 2 was advertising to router 1 for the 6th network, and we have changed that metric to a value that is lower than 500, which router 3 was advertising. We change it to 250, and now it looks like router 1 is preferring router 2 as the next hop to reach the 6 network. Let's go ahead and confirm this. We'll do a trace route to the 6 network. We'll source it from 1.1.1.1. And we can see the path that it's now taking is the 12th, the 24 to 6. So we are going router 2 to router 4 to reach the 6 network. However, when we trace to the 66 network, we are still going through router 3, which is the 13 to 35 path. Let's do the command show route receive protocol BGP. If we look at our networks we're receiving from router 2, the prefix the prefix 6.6.6.0/24 is now being preferred through router 2, as we can see with the asterisk, with the med value of 250. The 66 is not being preferred because it has a med value of 500, and we see from router 3 the BGP routes that we're receiving a lower med value for the 66 network, and that's why it's being preferred through router 3, and a higher med value for the 6 network of 500. And that's why it's not being preferred, not being the preferred path. So the end result that we see, that we have load balanced these two networks, a very simple form of load balancing from the ISP's perspective, our Autonomous System 200. We have influenced the way Autonomous System 100 will enter our autonomous system, and that is by sending a metric value to them. The last thing I want to show you is that if the link between R2 and R1 goes down, we should see all of the traffic reroute through router 3 to router 5. So let's do this real quick. On router 2, we'll just do the command set interfaces LT120.21 disable. We go to router 1. Now if I do a show route receive protocol BGP for router 3, we see that we have the asterisk for both of the networks, the 6 and 66. Do a show route protocol BGP terse. Both of those networks now being advertised only from router 3. And that's because if we do a show BGP summary, our link between R1 to R2 has now become active within BGP, so we don't have a adjacency formed. Let's do a trace. The 6th network is going through a router 3. And so is the 66 network. So we can see that the traffic has rerouted, all the traffic has rerouted over the only connection that remains up, and that's between router 1 and router 3 to reach the 6 and 66 networks. So that's it. That's our Juniper Border Gateway Protocol, BGP Lab number 6. We looked at the Multiple Exit Discriminator, our MED BGP attribute, in detail in this lab. I'd like to thank you for watching, and I hope to see you in the next video.